My project is about face detection and face recognition. I have searched about ways to how to detect faces, and I found you can do it from scratch, and you can use tools as well. And for me, I just wanna learn how to use tools, and I use MTCNN and HAR Cascade, and the difference between them is MTCNN is a kind of precise and have a lot of layers that can give you precise results, and how cascade is kind of performant. And for example, uh, here is my image. Yeah. And if you use it with MTCNN, it will go something like that. It's kind of precise. And if it's from the house, it will be something like that. So that's what I've done. And actually, uh, this is for the cascade. There is something that may be improved in the future is that we can actually evaluate between MTCNN and HAR cascade, like using for evaluation, something like that. And here is a kind of a real-time one. Doesn't show up, but yeah, I will go there after. So my second part is like doing face recognition, and I've used the Siamese network using the contrastive loss, because there is two kind of Siamese network, and I I focused on the Euclidean one. So I prepare the data. The data is actually from I collected from LFW and have got something like that, and I added some data of mine and prepared it like creating pairs, similarity pairs and dissimilarity pairs, like two similar images and two dissimilar images. And we've got like if we use that, I convert the data into CSV, and we have something like that. And then after the preparation, I split to test and train, because for the Euclidean one, it's like machine learning, and we don't compare the images, but the distance between them. So that's actually what I'm trying to train to images that go to the same weight, and then to to calculate the distance between them. I used for the images, I used face detection, like cropping the image just to the face, the frontal one, to be precise. I have tried it without it, and it returns bad result. So I kind of augment the result and pre-process the image. And then we have something like that for the image, like a cropped one from each of the image. And then it will be trained on the model, like adding layers. Um, it looks like embeddings for and it's for a text, and then it will convert it into vectors through the neural network processing. And that's actually the way that we need to that I have spent so much time to test the best one. And here is um, like calculating the distance between them. And when we train the model, I have used just like 32 sample, and then I have a trained dataset, and this dataset just from the train and test I have generated earlier. And at the end, I trained the model and got something like that from. This is my best so far, but I've tried a lot of weight uh, and methods, and this is the last so far. And this is one way that I have found during the process, like when we close all everything, it will be uh, lost. So we need to save the model in order not to waste them on it anymore. And then this is the prediction actually. So if for me it's comparison of two pictures, and for they will go into the same process, and then it will be predicted after. So I used Gradio for that, and um, so we have something like this. So for example, let's test um, and, and, and we test it, and if it fails, it said fail, and if it's a success, it's a success. But it's not actually perfect, but something like that. So this is the similarity score and the success. Let's test another one. Um, let's see. So, so, and it gets something like the similarity is low when they are not totally different, and sometimes it's rotated, something like that, or and if it's in the same pictures, it's not optimized with rotation and the lightning. So that's my project so far.